Greetings, everyone. This is Jeff Wilkerson, Professor of Physics at Luther College, bringing you the next in our series of what to look for in the night sky. This time we're talking about the week of January 2, 2023, so our first week of 2023. As the week unfolds, the moon is nearly full most of the week. It's at the beginning of the week, it's still filling out, it's still waxing, but already over 90% full. So if you go out on the evening of the 3rd, on Tuesday evening, the moon will be making a nice pairing with Mars and bright Aldebaran just below there. So go out on the evening of the 2nd, check out the moon, 94% full, right next to Mars, big bright moon. One night later, it will have moved to the far end of Taurus. So Taurus, we have this V of the Hyades, of which Aldebaran is part, and if you extend the upper branch of the V of the Hyades out, Elnath is the last star out in that string, and the moon the next night will be near Elnath and will be even fuller, 97, 98% full the next night here. A very, very close pairing, beautiful pairing there. Go out a couple of nights later on the 6th. So that's Tuesday, Wednesday, Friday evening, the 6th, just after dark. So the moon, as it's full, is up all night, so it really doesn't make too much difference when you go out to make these observations. Sort of what I've drawn on the board here would be evening, not long after dark, what this might look like. The moon's tracking to the left on the board here, tracking easterly through the stars. So the gap between these things is likely to open as the night wears on. If you go out a little earlier than what I've drawn, this probably 8 o'clock my time is what I've drawn, more or less. By the 6th, you've got Castor and Pollux there, the twin stars, and the moon sitting just below them there. Again, nearly full on the night of the 6th. We're starting to wane now as we move forward from here. So as the week progresses, Tuesday, Wednesday, Friday, watch the moon track easterly against the background stars, and watch it near Mars to begin the week, then Elnath, then Castor and Pollux, and enjoy finding those bright stars. Gemini and Taurus is what we're talking about, where the moon is this week. As we look this time of year, one of the good things to observe is Sirius is the brightest star in all of the sky. And so I write these things on the board in advance so that they're a little bit more legible instead of me trying to write them on the fly, and then I look at that and I can't even read it. When we start there. So there you go. Sirius, the brightest star in all of the sky, is now, we'd like to say, the north-south line directly overhead is the meridian. So wherever you are on Earth, you look up and you connect north to south, and you have, that's the meridian line that passes directly overhead through the zenith, is the point that's directly overhead. So if something is on the meridian at midnight, that's as high in the sky as it's going to get. It's up pretty much all night, like the full moon is. And so the full moon would be on the meridian at midnight, that line that connects north to south directly overhead. This week, Sirius is very near the meridian at midnight. So Sirius is about as high in the sky as it's going to get. It's there as night falls, as it gets dark. It'll be there most all of the night, depending on how far north you are. Those of us as far north as I am, Sirius is just enough south that it's not, it shortens the amount of time that we can see it in the sky. Big bright star. You look south, go out, you look southeast then, just as it's getting dark. You go out in the middle of the night and you look due south, and you've got the relatively familiar asterism of Orion here. There's the 3 stars in the belt of Orion, Betelgeuse and Rigel here, shoulder stars and leg stars that mark Orion. And so there's our pattern of Orion. And if you look down, the 2 leg stars of Orion, connect them over, move the same distance over again and drop down. There's Sirius. You don't really need to do that. Sirius is the brightest object in this region of the sky. So you won't miss Sirius, I don't think, if you go out and you look for it here. Fairly significantly brighter than any other star in the sky. So it's really, really significantly bright. It's in the constellation of Canis Major. Its nearest neighbor over here is Meridian, also a relatively bright star. So start with Sirius and see if you can find Meridian just off. It's a little bit closer than, it's angled downward. If you're here, so you're looking south at midnight, angled downward to get to Mirtzam a little bit, and the spacing between Sirius and Mirtzam is a little bit less than the spacing between the leg stars of Orion. So if you're using that as a guide, then you drop further down, bigger distance down this direction, and more closely spaced down here at the bottom, and maybe not as steep an angle downward as the way we've drawn it here. Wizan and Adhara are a couple of other relatively bright stars, but those are getting pretty far south for me to be able to see. Now's the best time to see them. I go outside at 10, 11, 12, 1 in the morning, and I get a good look at these stars. So we get something of a rectangle of stars here that make up Canis Major. And right below Sirius up this direction is open star cluster M41. Open star clusters have individual stars that you can see, relatively bright, relatively distinct, will hold up to the full moon that's passing by. So these are objects that we can go out and see and enjoy this week. So that's my recommendation for you, is enjoy Orion and Sirius, the brightest star in the sky, very near the meridian at midnight, very opposition, we would say, very if we were talking about planets. So crossing the meridian at midnight here is Sirius, about as far away in the sky from the sun as you can get. So about as well placed for observing as you're ever going to get right here. And so go out and enjoy this view. See if you can find M41 in a pair of binoculars or a small telescope down in here, and enjoy the moon as it's passing through here. Now we can think about Sirius. Sirius looks really bright. Stars we know can look really bright to us because they are close or because they are intrinsically luminous. They're glowing really brightly. You think about that, you take a 100-watt light bulb, and you have a 100-watt light bulb very close to you, and it's going to look really bright. It's going to look progressively fainter as you get further and further away with that 100-watt light bulb. But if I'm out here with a 1,000-watt light bulb, it's going to look bright like the 100-watt light bulb did in here close to you. So you've got these stars that are glowing, emitting energy at different rates. So some stars are brighter than other stars. Some stars are further away than other stars. Sirius happens to be both relatively bright, but not among the brightest stars in the sky, and relatively close. It is among the closest stars in the sky. So that's why it looks so bright, is it's intrinsically luminous. It's glowing brightly, but it's also very close to us, is even more important right here. So astronomers are very, very fond of making something called an HR diagram, where you plot the luminosity, how bright a star is intrinsically on this y-axis up this direction, and you plot how hot the star is. Blue stars over here, red stars over here. That means temperature actually increases this way. That's not the way you're accustomed to making a graph probably, but you're having temperature increasing across this direction. Then it turns out that most of the stars, 80–90% of the stars in the sky, are what we call main sequence stars. They're fusing hydrogen into helium in their cores, and you plot them on a graph like this, and they form a pattern, a band that looks this direction. They're not just all over the place. Now, how bright a star is proportional to both the radius of the star squared, the area of the star, and the temperature of the star to the fourth power. So the temperature of the fourth power means it's very sensitive to the temperature of the star, but it's also sensitive to the size of the star. So these bluer stars, these hotter stars, are more luminous because they have this much higher temperature here. So what you see is the sun is about right there, and Sirius is about right there. And so Sirius is significantly brighter than the sun, and it's bluer than the sun. But of the main sequence stars that are here, there are giant stars that are over here, and there are white dwarf stars that are down here. Of the main sequence stars, there are main sequence stars that are at least 100 times more luminous than Sirius. There aren't any very close to us. So if they aren't very close to us, they don't look very bright to us. Sirius has the advantage of being pretty far up this main sequence, pretty bright, but also it's within the 5 or 10 closest stars to us. So it's not among the 5 or 10 most luminous stars. Like I say, there are stars that are at least 100 times, main sequence stars, that are 100 times more luminous than Sirius is, but they aren't very close to us. But Sirius is among the 5 or 10 closest stars to us. So that makes it look very bright, that combination of being relatively near, very near really, and relatively bright. Now, the giant stars, when stars leave the main sequence, they've fused all the hydrogen to helium in their core. They become giant stars up this direction. That's a story for another time. They're fusing hydrogen into helium in shells around the inert helium core at that point. For this time, though, once they've gone through this process, a low-mass star like the sun, if you've got a star that's maybe less than 8 times the mass of the sun, then it will go through and become something called a planetary nebula. We've looked at those before, and we'll look at those again in the near future. But the core of that planetary nebula, when it's blown off its outer layer, you've got the core of that star left. That's what we call a white dwarf star. It comes down in here. And it's down in here. It's hot, but it's really subluminous. So the white dwarf star is very faint because it's very small. The surface area is extremely small, even though the temperature is high. And so this is the fate that awaits the sun. This is the fate that awaits all low-mass stars. And we bring this up right now because Sirius has a companion star, a binary. It's part of a binary system, and its binary companion is a white dwarf star. We knew for years that Sirius was part of a system of a binary system like that, because we could see it walking across the sky, and it was moving up and down. So it was orbiting something. It was orbiting with something we couldn't see. But they were able to block. If you can block the light from the primary star, this brightest star in the sky, then you can see the little faint companion in there next to it. And so you can't probably do that. You need better equipment than you have at home. But one can do that. One can do that, block the bright Sirius and see Sirius B. We call that Sirius A now, and we call this Sirius B is a white dwarf star down in here. We know lots of white dwarf stars. This was among the first that we found. We know lots and lots and lots of white dwarf stars out there. And so we see these stars. They are the cores of low-mass stars that have ejected their outer shells into space. So that's what we got for you this week. See if you can find Sirius, Mirtsem, Wezan, and Adhara, and see if you can find Open Star Cluster M41, and think about Sirius being bright, because it's both fairly luminous, but really close. Luminous and close is a great combination to be the brightest star in the sky. And then think about Sirius having a companion that's a very faint star and hard to see because it's a white dwarf star that's ejected its outer layer into space here. And we see it way down here on an HR diagram like that. Hope this was interesting for you folks. Hope you have clear skies and can go out and enjoy some of this. As always, thanks for watching, and we'll have something new for you next week.